Hi, welcome to Physical Science 2.1b. 2.1b is after we've done 2.1a, which was broom ball in the hall. So let's define some of those forces that I've already asked you about. When a force is applied to an object, its shape might change. That's called deformation. Like in this little stress ball, it's round, but when I squeeze it in, its shape changed. I applied a force. Or the motion of the object might be affected. It might move if it's already moving. You can change its direction by applying a force, and you saw that when you had to turn the bowling ball in broom ball. There are two general categories of forces. There are contact forces, those that require contact with the object, push, pull, squeeze, right? I can't make the ball crush in if I don't squeeze it. And there are field forces, those that act at a distance. For a field force, those are like gravity, meaning if I drop the ball into and through the frame, it's going to go down. It's not going to hover there all by itself. These are two examples of contact and field forces. Contact forces, you cannot in any way make the wagon go without the horses. And yet gravity, it's an unseen force and it holds objects to the ground or as close to the ground as possible. There are four forces of nature, but we're only concerned with one, and that's gravity. Gravity holds the stars and the planets together, and it depends on the mass of the objects. And then in chemistry, we'll start talking about electromagnetic, strong, and weak forces. Now, all four of those forces have what's called a force constant, a number that's associated with it that everybody, it's like an actual thing. Everybody knows that this is the force constant because it's been tested over and over and over and over again. Gravity, like I said, is the only one that we're concerned with, and it's got a lot of names. The gravitational field strength on Earth, or Earth's gravity, or the acceleration due to gravity. And they're all the same number, which is in the units of acceleration, which is 9.8 meters per second per second. The four main forces that we will study are the force of tension. It's horizontal or vertical contact with your object. The force of gravity, which will pull all objects straight down, always down. The force of friction that will go opposite the motion and it will cause objects to slow down. If an object's not slowing down, you can't say that there's friction. And then we have the force of normal. This is the force that is always with you. The normal force, it is normal for the floor to hold you up, normal for the table to hold your books, normal for you to be able to sit in the chair and the chair holds you. These are all normal forces, and they always come up from underneath. So, examples of forces and their effects. A force of tension is a push, pull, grip, squeeze, or hang. Okay, those are all forces of tension. And what you're going to be doing today, your goal, is to be able to identify a force and draw what's called a force diagram or a free body diagram. So anytime you see something being pulled, pushed, or hung, that's going to be a force of tension. The force of gravity will be on absolutely everything because we are on planet Earth. And it will pull all objects straight down. It's also known as the weight force. Then we have two kinds of friction. We have the force of friction from one object to another, right? But we also have the force of friction that is air resistance or aerodynamics. So anything in the air that is falling through the air, depending on the size of it and how far it's falling, it may have FF or air resistance or air friction. And then again, you have the normal force, the force that is always with you. So whenever we go to analyze forces, a force is produced by an agent. That is the thing that causes the force. A force acts on an object, the receiver, and the force causes something to happen. That's the effect. Now, when we diagram forces, we don't always talk about the effect, but you do need to keep it in mind so that you can really analyze the forces correctly. So a force diagram, this gets a little complicated because it's a double subscript, but it's the force type, meaning FF, FT, and then it's on and by. And what we mean by that is when you go to draw a force diagram, you reduce the object to a single dot. You label all of the forces acting on that object in that format, force type, on, by. A normal force is always perpendicular to the surface. So, if my hand is the surface and the pen is the normal force, if I tilt my hand, the pen tilts as well because it's always got to be perpendicular, making that perfect right angle with the surface. And then gravity, please remember, gravity always goes straight down no matter what. When you go to analyze forces, sometimes it's easier just to look at the picture and identify what you have, and you will always have gravity. So you draw a little arrow down, say Fg, force of gravity. Then, right, force of gravity on the boy by the earth, because the boy doesn't float, and earth causes gravity. Then we have the force of friction. It's diagonal up to the right because it's going to go the opposite of the motion. The boy's going down the slide, so the force of friction goes up the slide. And believe it or not, the boy is slowed down going down the slide. He would fall to the ground faster if the slide wasn't there. And then we also have the force of normal because the boy doesn't go through the slide. And we have the force of normal on the boy by the slide. So when you're looking for the agent, what causes it, think about the effect. Why does the boy not fall straight to the earth? Then when you actually draw that force diagram, it would look like this. And if I were to read this clockwise, starting from the 2 o'clock position, force of friction on the boy by the slide, force of gravity on the boy by the earth, and then a force of normal on the boy by the slide. Again, another example, a block sitting on a desk or a table. Turn it into a dot, right? Look for and identify the forces acting on the object. Draw the force arrows from the dot and label each arrowhead. So the block becomes a dot. We have gravity going straight down. We have normal going straight up. This is the force of gravity on the block by the earth going down, and the force of normal on the block by the table going up. You're going to be drawing force diagrams today in class. Thanks for watching.